Okay, we're ready to go. Have a seat, everyone. Welcome to the SDVoE Alliance booth. I'm Laurent from NETGEAR, and I'm very happy to present a very interesting concept. AV over IP is going to destroy your existing network. And believe me, it's very true. And I'm going to explain to you why it does matter when it comes to pick the right AV over IP technology for your installation. So as an introduction, why this topic is relevant, why you must know that AV over IP is going to destroy your entire AV over IP network. Because as we stand at this ISC 2020, one more time, and that's the same thing for multiple years, there's a lot of wrong debates and discussions around there when it comes to selecting the right AV over IP technology. All day long, we on the SDVoE Alliance that rely on high-speed, high-performance 10 gig Ethernet for video over IP transmission over Ethernet networks. We hear all day long that 1 gig only is the right way to go, because convergence can only happen at 1 gig, because 1 gig is free, 1 gig is everywhere. You got 1 gig already. And what the heck, you should stay away from 10 gig, because 1 gig can be used in your network right now. This is what you have. You're better off. So all that is a red color, because now it's the right time for me to tell you that it's not true. This does not work this way. The fundamental point is that AV over IP can be 1 gig or 10 gig or anything else. AV over IP will always require a brand new, capable line rate network. None of the existing network is capable of transporting AV over IP in a non-blocking fashion. And the problem with video over IP is that it does require a lot of bandwidth, because video cannot be queued. Video cannot be prioritized against other types of traffic. So whether we go with the 1 gig video over IP installation, or we go with a higher performance 10 gig video over IP installation, 10 gigabits will be required in any case. So maybe now it's time for me to explain to you why, okay? IT networks are built this way. For now, almost 25 years since the beginning of Ethernet networks and TCP/IP, Ethernet networks are based on a star system with a core switch, a core on the network, a core layer connecting access switches in a star topology. Of course, if you have larger organizations like a university, like a large school, a large venues, or a typical enterprise headquarters here in the Netherlands, you might not have enough connectivity at your core as an IT organization. So you will add a third layer between the core and the access. We call this the distribution layer. And then you have a topology with access switches where you and myself, we are going to connect. And then those switches will connect back to this distribution layer, aggregating all this data. And this traffic will be moved up to the center, to the core of your network. 2-tier networks, 3-tier networks, 99.9% of those networks are not line rate. They are not capable of transporting video over IP. The reason is that from the early days of fast Ethernet with TCP/IP and Ethernet, you may remember that all of us used to be fast Ethernet, 100 megabit per second at the edge of those networks. And those networks were built very nicely with gigabit uplinks. So a lot of 100 megabit per second of devices at the bottom, and 1, 2, 3, 4 of these gigabit uplinks aggregating nicely this bandwidth to the core. Everything was all right. But something happened at the end of the 90s, right? We all went gigabit to the desktop. So all these access switches were replaced with brand new 1 gig Ethernet switches, and all of us now connect with our phones or IP phones or tablets or PCs or access points, printers at 1 gigabit per second speed. But the networks never changed, really. Most organizations kept a gigabit aggregation with a lot of oversubscription, even though some organizations, maybe a university, upgraded some of this uplink capacity to the 10 gigabit Ethernet speeds. It is never in a line rate fashion, because aggregating tons and tons of gigabit speeds would require a ton of 10 gigabit uplinks capacity, and in normal IT networks that would be a waste, a pure waste. By the book, IT administrators are very much used to deploy Ethernet networks with a 20-to-1 oversubscription ratio. It means that only 10 to maybe 30, maybe 50% in best cases of this bandwidth is aggregated to the core. And the reason is that IT does not require line rate installations. PCs do not need any line rate installation. And now let's have a look. What is AV over IP? How does it work? It's actually really simple. It looks like we are going to use the same network, but we are not, right? Because even if you have only 5 of these encoders connecting those video sources on the top right, only 5 of them, and even though they are not even SDVoE capable, even though they are only 1 gig Ethernet, 1 gig per second encoders, if you have 5 of them, you might require 5 times 1 gigabit of video streams as a bandwidth capacity when you are going to send those videos and traverse the rest of the network. And this is never the case. So let's say you have one floor with your 5 sources, 5 encoders with a codec of some sort doing 1 gig video over IP. If you do have 5 encoders on the top right, how much bandwidth do you need to go to the second floor on the bottom left? What is going to be this bandwidth? You have 5 encoders of 1 gig each. Well, that might be 5 times 1 gig per second. In that case, here we only have 2 receivers on the first floor on the bottom left. So because we have only 2 streams might actually come at any period of time down there. So in that example, 2 gigabits per second are required. This is already way more than 1 gig per second. So as soon as we have more than 1 gig per second, it means that 10 gigabit is most likely required even in a such small installation. So I don't know for you, but I think that most of us are really proud of our plumbing system at home, right? The plumbing system is good, I have a good water flow. But you may know that whatever the size of your tubes and inputs and outputs in your system, your overall water flow will always be restricted to the smallest section capability of your plumbing. Here, my P2 small section under the house is restricting my entire delivery, okay? And even if you have some 10 gig here and there, the overall networks are always limited to the smallest section in between switches. And that happens all the time. Now, let's take a real-world example. Let's say you have a job coming up and you have 60 encoders, 60 video sources, and you want to build a matrix with 60 decoders. So 60 sources, transmitters, 60 decoders on the other side. And let's say, for the sake of this example, you still want to use 1 gig video over IP with a codec of some sort, 60 by 60. If you have one floor with 20 of these sources, another floor with 40 other sources, then you do require 20 times 1, 20 gigabit per second of bandwidth to move those 1 gig video streams to the center of your network. If you have 40 streams delivered by the second switch on the upright, you will need 40 times 1 gig per second to flow down to the rest of your network. So see, 2 plus 4, you need 6 10 gig links entirely available for your application in that example. And reversely, if you have another pack of 40, this time receivers that will receive those multicast packets, that's another group of 4 ports of 10 gig Ethernet that will be a strict requirement for your installation. So 1 gig over IP is all about 10 gig, okay? And none of the existing networks can do that. So it does mean that in any case, normal IT networks cannot handle that. There is no such so-called convergence at all. AV over IP, in particular video over IP transmissions, will always require a specific, dedicated, new infrastructure. If you compare the entire network at the customer with an ocean, you will have to build islands, okay? Islands with line rate connectivity between your T-axis and R-axis. Now, let's take another real-world example. This time, you want to have the best quality. You want to have native video quality. You want to have zero flame latency. So for that, you want to use the SDVoE technology. With SDVoE technologies, this time you have transmitters connecting your sources. Each single of them will work at 10 gigabit Ethernet speed to remove compression and latency. 72 sources, 72 receivers. This time we need even higher capacity for the aggregation. If we have an even distribution between 3 floors with 24 sources and 24 displays on every floor, then we do need 24 times 10, 240 gig per second of bandwidth available to move those streams to the other switch in that case, where we have another group of 24 receivers. 6 times 40 gig Ethernet links would do the job, because 6 times 4, 24, 240, this is the right count for 24 at 10 gig. And because, well, Ethernet is by nature bidirectional, you have full duplex everywhere, so those 240 gig Ethernet of bandwidth in between switches are bidirectional. This is the full duplex operation, so you can simultaneously send 24 sources down, and that switch can receive 24 other streams of 10 gig in the other direction. It means that in this triangle, which is nothing else than another star topology, you do have line rate capacity between any transmitter and any receiver, but using a higher 40 gig Ethernet uplink capacity. So, this is the conclusion, and next your questions will be welcome. But when it comes to AV over IP, when it comes to the planning stage, don't be obsessed by the 1 gig versus 10 gig odd discussions, because now you know that none of the IT networks is going to be ready anyway to support, to handle your AV over IP installations. Whatever it is, 1 gig or 10 gig, you will always have to plan for a capable, specific, adequate network topology. So now the real question is, why are you going to choose 1 gig or 10 gig? Okay? And this might not depend on the network then. The real important things are your requirements. Do you require perfect native quality, untouched quality? Do you require zero frame latency, absence of latency, microseconds of latency? Or no? If you do not require perfect quality, and if you can sustain hundreds of milliseconds of latencies, plenty of frames of delays, then 1 gig might be an option. If you have an operating room, if you have a large venue like the Opera House in Amsterdam with the show on the stage and those cameras filming the singers, displaying their face in high format and resolution on the screens, if you can't handle any latency because you can't have any visual delay between the real show, the live show, and the videos. Surgery rooms are another good example. You may not want your surgeon to have some issues with latency when he's operating within your body. Then you absolutely require a 10 gig infrastructure. And again, none of it matters when it comes to the network installation, because you will have to plan for a capable line rate network with most likely a good, solid, non-blocking 10 gig architecture. Thank you for your attention. That was a great occasion. Again, this is Laurent from NETGEAR. Any question are welcome on the SDVoE booth. Thank you.